Here we have a piecewise function. So a piecewise function is a function that is defined by two or more equations or pieces, each of which applies to a different part of the domain. The graph of the piecewise function can be continuous with no breaks or gaps, or it might be discontinuous if there are breaks or gaps. So looking at this example, we have three pieces to this equation. Our first piece is we would graph negative 1/3 x minus 4/3 as long as x is strictly less than negative 2. So that must be this piece here. These have x values strictly less than negative 2. The next piece says that the y value is negative 1 as long as x is between negative 2 and positive 1, and it can also equal negative 2 and 1, so less than or equal to. So it's this piece here, including these endpoints, because it can be equal to negative 2 and 1. And our last piece is that we have negative x squared if x is just bigger than 1. So it's going to be this piece on. So we have three pieces to our piecewise graph. And since we could technically trace this graph without picking up our pencil, we could trace this whole thing. There are no breaks or gaps, so it would be what we would consider continuous. There are no breaks or gaps. There's no spot where I have to pick up my pencil because the graph picks up down here or something like that. There's no breaks in this. So the first thing we're asked about is what is the domain? So remember, domain is reading left to right on our graph to see what the x values are. So to the left, it's going out to negative infinity. That arrow says it's going to keep going. So we're going to start at negative infinity, and we're going to go out to the right, which also has an arrow. So we're going to keep going to the right to positive infinity. So our domain is going to be negative infinity to positive infinity. And remember, you never include the infinity, so those are round parentheses. Range is reading down to up on the graph. We're looking at the y values. So reading down on the graph, here's the lowest point of the graph, and it looks like it's going down to negative infinity. And then as we go up, there's an arrow that says it keeps going, so it looks like it's going to positive infinity. It's going to keep going up as the graph continues. So it's going down on one side and up to the other. So down to negative infinity, and then also up to positive infinity. So the range is going to be all real numbers there too. And then we're asked to plug in a couple points. So if we want to plug in f of negative 4, I want to find the y value for the x value, negative 4. Remember, you always plug in f of x, and that equals y. So x must be negative 4. And the y value at negative 4 is 0. If we do that same thing here, x is 1, and we want to figure out what y it goes to. So x is 1 is right here. And the y value on the graph is negative 1. So we just plugged in to a piecewise function. Not too bad when you have a picture of the graph.